Hi everyone, this is Meghna Kotpati with CWID 50309079. This is my final project on Automata theory, travel management system via flight. Coming to the description of the project, the project's main purpose is to develop an application that allows users or customers to book flight for trips. Customers can even communicate their tastes and preferences. The CKY parsing algorithm is used in this project. A CKY method is a context-free membership algorithm. It is named after its developers, Koke, Younger, and Kasami, the three data computer scientists who worked on this special parsing technique on a CNF grammar. So what is CNF grammar? A grammar must be in Chomsky normal form, in CNF form, in order to use CKY algorithm. Like a grammar, like when we consider a normal grammar, which is context-free grammar, it must be free from unit productions and null productions. That is, there should be no productions which points from non-terminal to null symbol or non-terminal to another non-terminal symbol. If a grammar is free from this unit productions and null productions, then this grammar is called Chomsky normal form grammar. And this grammar is used for CKY algorithm. In this project, we have considered multiple valid sentences like, can I book flight? Do you want this flight? I need this airlines. What is the airlines? Can I cancel the flight? Can I book flight tomorrow? Book the flight for California. What time is the flight? Do you prefer this airlines? Do you need this airlines? Do you need this flight? I want this flight. I need this flight. Book the flight for Austin. Book the flight for me. And we have also considered 4 invalid sentences like, this is the flight I want. This flight can. This is the flight I need, and flight me. Coming to the grammar we have used for this project. This is the grammar, the context-free grammar we have considered for this project. If you observe carefully, there are few unit productions like a non-terminal pointing to another non-terminal here, and there are multiple instances where a non-terminal is pointing to another non-terminal. So the next step would be to convert this context-free grammar to Chomsky normal form, converting CFG to CNF. Here we eliminated all the unit productions. So there is no production such that a non-terminal is pointing to another non-terminal. This is the entire perfect correct format of Chomsky normal form grammar. Next, coming to the CKY tables. CKY is a right upper diagonal table. The values of the CKY table are found from bottom to top, like in this manner. And the indication that a sentence is accepted by the grammar is such that the final cell must contain a symbol, start symbol, which indicates that this sentence is accepted by the grammar. So, can I book flight? This sentence is accepted by the grammar, as in the right upper diagonal matrix, the final cell contains a symbol. So, for 15 sentences, we have constructed 15 tables, each containing a symbol in the final cell, indicating these sentences are valid sentences. What time is the flight? So the final cell contains a symbol. So this sentence is also accepted by the grammar. I want this flight, a symbol, yes, yes. And the final sentence and the final table contain S. So this is also accepted by the grammar. Now we look at the CKY parsing table for the invalid sentences. These are the invalid sentences, right upper diagonal CKY tables. See, at the last cell, we can see there is no symbol, which means this sentence is not accepted by the grammar. Here we can see there is a symbol, like there is a non-terminal symbol, but there is no S symbol, which means this sentence is also not accepted by the grammar. Let's coming to the coding part. I have done this code in Python. Let me show you the execution of it. I'm running this code in Jupyter Notebook. And all the grammar we have considered, like the grammar which is in the correct format. I've saved all the grammar in this grammar file. And we will give this as the input to this code. I'll show you the execution of the 50 invalid sentences under invalid under 4 invalid sentences I have taken. We will look at the outputs. When the code is executed, we will be prompted to enter a sentence. Let me enter the first sentence, like, can I book flight? Since it is a valid sentence, the output is yes. Let me enter one more sentence. Do you want this flight? Enter. Yes. I need this airlines. Enter. Yes, this is also a valid sentence. Let's run one more sentence. Can I cancel the flight? Enter. Yes. Can I book flight tomorrow? Can I flight tomorrow? Enter. Is also a valid sentence. Book the flight enter. This is also a valid sentence. Time is the flight. Enter. So all the valid sentences, as we have seen before in the CKY parsing tables, as they have a symbol in the final cell, these sentences are accepted by the parser. Let's run for the 9th sentence. Do you prefer this airlines? Enter. Yes. Do you need this airlines? Enter. Yes. I want this. Enter. Yes. I need this flight. Enter. Yes. The flight for Austin. Yes. And for the final sentence, book this flight for me. Enter. Yes. So these are all the valid sentences which are accepted by the grammar. And let's now run for invalid sentences. This is the flight I want. Since this is an invalid sentence, as we have seen in the CKY table, the last cell in the right upper diagonal matrix doesn't contain a symbol, so we get the output as no. Let's try one more sentence. This flight can. This flight can. Enter. No. Let's try for this sentence. This is the flight enter. No, we are still getting output as no, because as we have seen before in the CKY parsing, in the CKY table, it doesn't contain a symbol in the final cell, so the sentence is not accepted. And coming to the final sentence, flight me. This is also invalid sentences, the final invalid sentence. And coming back to the documentation, I have shared the screenshot of all the valid sentences. Like, can I book the flight? Yes. Do you want this flight? Yes. All the outputs we have got, the screenshot of all these outputs. And I have also mentioned the invalid sentences outputs, like this is the flight I want to get the output as no. As I have shown before, I have mentioned all the screenshots over here. And the video link of this demonstration will be displayed over here. Thank you.